Hello students, in today's session of inverse trigonometric functions, very basics will be clear through illustrations. In earlier session we have discussed all these things. In this case, illustrations were taken from JEE Main, which you can review on SethiSwiftLearn. I will also like to request, अगर अभी तक आप SethiSwiftLearn YouTube चैनल के साथ नहीं जुड़े and you like the videos contents, then share it with your friends and like it and subscribe it also. Now let's start with the concept and questions. Concepts and inverse trigonometric functions are: to find the inverse of a function, necessary condition should be bijective. Bijective means 1, 1 and 1, 2. Inverse trigonometry is obtained by restricting the domain and ranges of the functions. What is the meaning of one-to-one function? One-on function means that function never takes the same value twice. Trigonometric is a periodic function, that is, they take same value periodically. So their inverse does not exist. But if we restrict their domain and range, their inverse may exist. Just for example, inverse of sine function. Value of sine function varies from -1 to 1. That is range is, and for minus pi by 2 it is -1, and pi by 2 or it is 1. Similarly, because it is periodic, एक cycle, दूसरी cycle, इस तरह से इधर चलता रहेगा. So number of interval will be there. This. Value sine is also in the range of -1 to 1. If we restrict the sine function to any interval, either this or this or this, then inverse can be found out. Then it becomes 1 to 1 on 2. Then its inverse can be found out. Then inverse of the sine function is whose domain is -1 and range is maybe any. If we restrict this one, first branch, this is called principal value branch. This is called principal value branch. So domain of sine inverse x will be -1, 1 and range will be -pi by 2, 2. This is the principal value branch. Similarly, we can restrict the for other trigonometric functions, right? Now, domain sine inverse x -1 to 1, close it to -1 to 1, -pi by 2 to pi by 2, 0 to close interval. This is close interval. Tan of inverse x. Domain R, its domain is R. This is -pi by 2 to pi by 2 open interval. This is 0 to pi open interval. In this case, this is right. In this case, -pi by 2 to pi by 2 except 0. 0. Second version 0 to pi except pi by 2. These are the outcomes, right? Now, this will be sine versus sine theta, theta, cos versus cos theta for all 60 whatever. If theta belongs to this one, right? And for inverse sine of sine of, then x should belong to this one. X should belong to this one. This is all about basic how to find domain, how to restrict the domain, and how to restrict range, how to make it bijective function, right? Now let's start with the question. Question is, find the principal values of cosec of inverse 2 and cosec of inverse -2 by 2. It is a case of inverse trigonometric functions, domain of and range of. Domain of is mod x 1. That is, x should be greater than or equal to 1 or x should be less than or equal to 1. Or minus infinity to 1 union minus 1, 1, 2. We can write in this way, we can write in this way, we can write in this way. And range of the function, this is the range of the function. The range of the function is minus pi by 2 to pi by 2 except 0. We know sine inverse 0 is 0, so that will become non-defined at cosec inverse x. Or we can write minus pi by 2 to 0. This is the closed interval union 0 pi by 2 closed interval. This is regarding the now. You know, sine of inverse, cosec of inverse is reciprocal of 1 by 2. तो 1 by 2 साइन के केस में होता है 30 डिग्री, इस केस में होगा 60 डिग्री. दिस बिलोंग्स टू ऑल सेटिस्फाइड कंडीशन. Therefore, cosec of inverse 2 belongs to domain. Therefore, value will be pi by 6. Pi by 6, that will be the answer. Right? And cosec of inverse minus 2 by root 3. First of all, check. This belongs to domain. Belongs to domain. Root 3 by 2 is the value of 60 degree. So minus 2 by root 3 will be equal to 60 degree. It is negative. So minus pi by 3. Minus pi by 3 will be the answer of this question. Minus pi by 3 will be the answer of this question. Right? Next question. Find the set of values of cosec of inverse minus 1 by 2. Domain of cosec of inverse x is mod x greater than or equal to 1 or minus infinity minus 1 union 1 infinity. Minus 1 by 2 does not belong to this domain. Therefore, set of values of cosec of inverse minus 1 by 2 will be null set. Right? Next question. Question is, for the principal values, evaluate each of the following. In this case, tan inverse, sec inverse, cosec inverse. Domain, range, tan inverse. Tan inverse domain is R. Range is minus pi by 2 to pi by 2. Sec of inverse x. Sec of inverse x is mod x. Range is 0 to pi except pi by 2. And cosec of inverse x. Cosec of inverse x, that is 1 minus pi by 2 to pi by 2 except 0. Except 0, right? We know all these things. So in this case, root 3 belongs to its range. Root 3, the answer is pi by 3 minus sec inverse 2, sec of inverse minus 2 means it is 0 to pi. It means it will come out to be second part 2 pi minus pi by 3, that is 2 pi by 3, 2 pi by 3 plus, this also belongs to this domain, 2 pi by 3 root 3, that is pi by 3. On simplification, pi by 3 plus 2 pi by 3 minus 2 pi by 3, answer comes out to 0. Answer of this is 0. Second question is 2 sec of inverse 2, 2 sec of inverse 2, 2 sec of inverse 2, 2 into, that will be equal to sec of inverse 2, 60 degree, pi by 3 minus 2 into, this comes out to be pi by 6 minus pi by 6. On simplification, we get 2 pi by 3 plus pi by 3, that is 3 pi by 3, that is pi. Pi is the answer of this question, right? Next question. Question is, if cosec of inverse x plus cosec inverse y plus cosec inverse z equal to minus 3 by 2, then find the value of x upon y plus y upon z plus z upon x. As maximum value cosec of inverse x is pi by 2 and minimum value is minus pi by 2. Answer is minus 3 pi by 2. So minus pi by 2, minus pi by 2, minus pi by 2. Therefore, cosec of inverse x equal to minus pi by 2, cosec of inverse y equal to minus pi by 2, and cosec of inverse z equal to minus pi by 2. Right? Minus 2 is minus 1. Therefore, x equal to minus 1, y equal to minus 1, z equal to minus 1. Substituting the values to find value of x upon y plus y upon z plus z upon x. Substituting values. Minus 1 upon minus 1 plus minus 1 upon minus 1 plus minus 1 upon minus 1. 1 plus 1 plus 1, that is 3. That is the answer. Right? Now, I will request, if you are new to my YouTube channel, SethiSwiftLearn, and like this video, please subscribe and share the channel, press bell icon to receive updates on concept killing videos. Thank you.